Hey there, welcome to Pomodoro Joe for Saturday, October 28th, 2023. Today we're looking at LeetCode problem 1220, count vowels permutation. This is a hard problem. All right, so we're given an integer, n. Our task is to count how many different strings of length n can be formed under the following rules. Each character is a lowercase vowel, a, e, I, o, or u. Each vowel a may only be followed by an e. Each vowel E may only be followed by an A or an I. Each I may not be followed by another I. Each O may only be followed by an I or a U, and each U may only be followed by an A. All right. Since the answer may be too large, return it modulo 10 to the 9th plus 7. Okay. So we're given an integer, n, and we know that our strings can only consist of lowercase a, e, I, o, or u. And then we have some rules to follow in building our strings. Now we don't actually have to build the strings, we just have to return the number of strings. So that's good to know too. Now example 1, n is 1. Well, we can have a, or e, or I, or o, or u. So that's 5, and we return 5. All right, n is 2. So these are all the different options, but basically you can have an A, and then it has to be followed by an E. So that's the only one that can be an A starting string. So A, E. And then you can have an E, and you can have it followed by an A or an I. So you can have an EA or an EI, and so on and so forth until you get to your last input or your last string, and that's 10. Okay, let's put 25 minutes on the Pomodoro timer and we'll get started. I don't think this one's actually going to be that bad. So we're going to start with doing a recursive solution. We'll see how that goes. If it's too slow, then we can try an iterative solution. But let's just start with the recursive solution. And let's define our function here. We'll have an internal recursive function called count vowel permutations recurse. All right. And let's see, for this one, we'll take, what do we need? We'll need to know what the previous character was. So we'll keep track of the previous character. And we'll need to know how many of these n we still have left, how many characters left. So I'll have it remaining n. And for now, I'm just going to pass. Okay, so we're going to have this function that basically we pass in the previous character, or our current end character of our string, and the number of characters we have left. That's the remaining n. And it's just going to return the number of strings that we can create. All right? So then to kick this whole thing off, let's see, we'll have some result. We'll set it equal to 0. And then we'll need our vowels. So let's see. And the vowels are just A, E, I, O, or an U. All right? And so for every vowel in our vowels, our result will increase by the call to this function. So basically, well, let's do it 2 steps. So one option is to start a string with this vowel. So for every vowel in A, E, I, O, or U, we're going to start our string with that vowel, and then we'll just call this function here. Passing in this character, so this vowel, as our previous character, and then remaining n is just n minus 1. All right, and then our result will increase by this option. At the very end, we return our result, modulo 10 to the 9th plus 7. So let's actually create our mod value out here. That's 10 to the 9th plus 7. So we'll return our result modulo our mod value. Cool. All right. So for every vowel in A, E, I, O, or U, we'll just go through, what if that vowel was the starting What if that vowel was the starting character of our string? What will be our number of strings we could create starting with, let's say, A, E, I, O, or U? And then we'll just increase our result by the number of different strings we can create starting with that vowel, and we'll return our result at the end. Now for our count vowel permutations, all right, since this is a recursive function, we'll start with our base case. And that's if our remaining n, we have no more characters left. So if our remaining n here is equal to 0, That means we have no more characters we can add, but we did make it here, so we can return. This was one option. We got one string. All right. And that's kind of the only one we need, although I think I'm going to take it one step further. I'll add one more base case just because it might save us a little bit of time. Let's say we have one n left. If remaining n is equal to 1, so we're allowed one character. Now it kind of depends what our previous character was. So for example, if our previous character was an A, we can only add an E now. All right, so we have one option. If our previous character was an E, we can only add an A or an I. So that's actually two options. If our previous character was an I, well, we can add anything but an I. So we can do an A, E, O, or U. Okay, so let's try that first. So if our previous character, if this was equal to an I, well then we're allowed to add an A, an E, an O, or a U to the end of this string ending in I, and that gives us 4 options. We can just return 4. All right. Now if our previous character was an A, let's see. Well, I could check each one. If it's an A, I could return 1. If it's an E, I could return 2. If it's an O, I can return 2. And if it's an U, I can return 1. Or I can do, if previous character is in, let's see, A and U both return 1. All right, so if A is in A or U, all right, so if our previous character is in this string A or U, meaning is that previous character an A or is it a U? If that's the case, then we return 1, because there's only one option. From the A, we can only go to an E. That's the only last character we're allowed to use. And from a U, we can only go to an A. All right, otherwise, if we make it past all of this, then we had an E or an O, and we can have 2 options. So we'll return 2. Okay, so those are our base cases. We have the base case, we're out of characters, but we made it to the end, so that's one string. Otherwise, we have one character left, and it kind of depends on what this previous character is. So we either return 4 if it's an I, 1 if it's an A or U, 2 if it's an E or an O. All right, now we have all of our other cases. These are the recursive cases. Let's just start from the very beginning. If our previous character, if that's an A, okay, if our previous character is an A, then we can only add our next character as an E. So our option here, well, that's equal to, well, we'll call our recursive call. So we'll recurse, passing in an E as our previous character. So we'll add an E to the end of our string, and then we'll have to reduce the number of characters left in our string by 1. So remaining string, or remaining n minus 1. All right. So we're taking this current string, we're adding an E to the end, and we're reducing the number of characters by 1. And then we can return this option. So I'm actually not even going to bother with the option. I'm just going to return. All right. So if our character is an A, the only thing we can do is add an E and reduce our string by 1, and we just return that. And we can do the same thing for an I, O, and U. So let's see. Let's do E next. So A and then E. Now E is a little bit different because with an E, we're allowed to add an A or an I. So let's see. We'll have 2 options here. Option 1, we'll do count permutations recurse on A, because we can add an A, or we can add an I. So option 2, we can add an I. All right, so option 2, we'll add an I. And then we can return the sum of these 2 options. How many characters or how many strings can we create if we add an A? And then how many strings can we create if we add an I? So then we can return option 1 plus option 2. All right, so that takes care of A and E. Now we have an I. So I is going to be a little bit different. So I has 4 options. All right, I think I'm just going to copy this and double it up. So an I is allowed to be followed by anything except another I. So with our I, we'll actually have 4 options. So add 3 and 4. And let's see, we can do an A, an E. We can't do an I, but we can do an O, and we can do a U. And then we'll return option 1 plus option 2 plus option 3 and option 4. All right, now we get to O. So O only has O has 2 options. So with an O, you can add an I or a U, so that's just like this E. So we'll grab this one. And let's see, this will be an O. And that can be an E or an I. No, an O can be followed by an I or a U. Let's see, this is an I or a U. I'll do U and then I, it doesn't really matter. And then the last one is a U, and that's very much like this A. So let's do this one. And let's see, the U can only be followed by an A. So U and A. Cool. And we've returned out of every single one of these conditionals, so we don't have to add any other returns here. All right, that's pretty much it. We're just following the instructions. If we had an A, we can recurse on E. If we had an E, we can recurse on A and I. I, everything but an I. O, U and I. And finally, U, A. All right, I think that's pretty much it. Now we might be able to speed this up a little bit, and I think this is already kind of big and I don't want to take too much more time. So let's just try to add a cache here to speed this up. So you could do dynamic programming. I'm going to use the Python way, just add cache. All right, so that should speed that up. And I think that's it. Let's run this, see how we do. Okay, seems to work. Let's see if we can pass all the tests. And we pass. Let's see, we don't do great. We only beat 21% for runtime and about 5% for memory, so that's not the best solution. We can jump back here and do a couple little things to speed this up. One thing we can do, currently we're just returning directly. I guess on these options it's not so bad, but these are going to be big. We're not doing any type of modulo here. Like we're waiting till the end to do our modulo. So we could actually add our modulo to the end of all of these. So we could do modulo mod val. And that might actually speed this up a little bit because we'll be working with smaller values. So let's try this. All right, and we can actually, do it again here too. So everything gets moduloed. Okay, let's see if this saves us anything. All right, looks like a little bit of a boost. We went from a 20-something%, 21% for runtime and 6% for memory, or 5% for memory, to a 32% runtime, 7% for memory. So it gives us a little bit of a boost. We're still pretty low on this graph here. So let's jump up here and see how other people solve this. The bulk of the solutions, ooh, look how nice and compact that is. Oh, so they're doing it iteratively. So we did a recursive solution. This is basically the iterative version of the recursive solution. So this DP here is like our cache. They're actually just going to store their values directly in this little array. And each one of these will map to a letter. So this would be A, E, I, O, and U. So that's pretty smart. I like that. Very compact. It's harder to understand what's going on because it's hard to read this and say, oh yeah, I totally get what this is doing. But it seems to be doing well. I mean, it's, actually, I don't know what percentage that is. And we can go way at the end. Whoa, this one looks way more complicated. Whoa, this has a matrix. This one could be cool to try to study. study this one and really understand it, because this one looks pretty fancy and it's the fastest one. Maybe I'll have to do some studying and come back and do a video on that one at some point. All right, well, I think that's it for me. So for this one, it's actually pretty straightforward. We just followed the instructions laid out in the problem in description here. So we'll go through, start every single possible string with our A, E, I, O, or U, and then we'll just keep recursing, adding new vowels, following these rules, and just keep count of how many different strings we can make until we get to our base cases. And that's about it. All right, well, I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.